was on mute, I guess, so I will repeat again. A warm welcome to everyone. IEEE-WI welcomes you all on board for Master Your Basics 3.0, a session on machine learning. Our very own core members would be the speakers for the event. The speakers are Tisha Chawla and Harika Neshidham. We look forward to your active participation to make the most out of this event.
Hi guys, good morning. Welcome to our session. We're really happy to see you all wake up early in the morning on a Sunday morning to attend the session. So this session is hosted by IEEE-WIE, which stands for Women in Engineering, and it's a platform that motivates and encourages women to take up a career in STEM, a career in the tech field. Today, my friend Tisha and I, Harika Naishidam, we will be walking you through the basics of machine learning. And it will be a great journey. We hope you stay till the end because we have some super interesting, super fun projects to do as well. Tisha, would you like to introduce yourself?
Yeah, hello everyone. I am Tisha. I'm also a core committee member of IEEE-WI, and it's really great to see all of you here at a Sunday morning, as Harika mentioned earlier. So, yeah, let's start.
All right. I'll just share my screen.
Yeah.
Do you think we should wait for a few minutes so that a few more people join?
Mm, I think it's 11:05. We could start.
All right. Okay. Okay. So machine learning. Okay. Just a moment. I'm so sorry. Is my screen visible?
No, Harika.
Is it right now?
No.
Roshni, could you make me the presenter?
I guess it's visible now.
All right. Okay. Okay. Um, Machine learning. It is an increasingly common concept, and it's a buzzword that finds its way into science and technology news every day. And ever since you got into college, you must have heard this word several number of times, be it from your professors, friends, or anywhere else. But what is machine learning and what is it used for? So let's take a look at everything you need to know about the basics of this fascinating technology. As well as exploring the machine learning definition, we'll also look at some of the different types of machine learning algorithms which are currently in use and what their applications are. So let's start at the very beginning with the definition of machine learning. If you quickly search for the phrase, what is machine learning, you'll get a whole host of different results and definitions. From a simple definition to the complex one, there are many ways to define machine learning. But let's take into consideration the most basic definition of it. We can think of machine learning as the science of getting computers to learn automatically. It's a form of artificial intelligence that allows computers to act like humans and improve their learning as they encounter more data. With machine learning, computers can learn to make decisions and predictions without being directly programmed to do so. The process uses algorithms to build models that can be applied to a whole host of different purposes. But at this point, you may not have understood how important machine learning is for us. So, let me talk about the applications of machine learning to show how our life basically revolves around machine learning. Okay, so the pictures that I'm showing here, you must have recognized them. So let's start with Google Maps. Personally, I don't think I can function normally without Google Maps on a daily basis. Using the location data from smartphones, Google Maps can inspect the agility of shifting traffic at any time. And moreover, maps can organize user reported traffic like construction, traffic, and accidents. And by accessing the relevant data and appropriate fed algorithms, Google Maps can reduce computing time by indicating the fastest route. And then we have riding apps like Uber and Ola. From how to fix the price of the ride and how to minimize the waiting time to how do riding cars fix up one's trip with other passengers to lessen diversion? Yes, machine learning is the answer. Machine learning assists the company to estimate the price of a ride, computing optimal pickup location, and ensuring the fastest route of the trip. And also, it detects fraudulent businesses. Now, if you have ever opened the Gmail app, you have this section called spam mail, right? So, have you ever wondered how mail gets segregated into spam mail and the other sections on which are available on the mail? Well, again, machine learning is the solution to this. Some rule based filters aren't served actively in an email inbox, such as when, for example, a message comes with the words online consultancy, online pharmacy, or from other unknown addresses. Here, machine learning offers a powerful feature that filters email from a variety of signals, words, and metadata of messages. Now, let's take a throwback to 2014, all right? So, do you guys remember when we would take pictures with the dog filter or the flower crown filter? Or if not those filters, we must have used filters somewhere at some point in our life, right? So, how do these filters work and how are they made? Well, machine learning is again the solution. And it offers machine learning offers facial filters that filter and track facial activity and permits users to tag animated images or digital masks that shift when their faces move. Um, so when you post something on Instagram and you want to tag your friends, the box there detects the face and then you tag a person, right? How is that done? Again, machine learning is the answer. From Siri to Cortana to Google Assistant, there are plenty of functions when it comes to personal assistant, along with Amazon Alexa and Google Home. For some people, these are even their best friends at home. By implementing the AI to its entirety, these home devices and personal assistants follow one's commands, including setting a reminder, searching online information, controlling lights, etc. Now, on a daily basis, there are a lot of transactions that happen, a lot of transactions of money, a lot of transactions of data. So it becomes important to secure them. Talking about fraudulent business transactions, daily business transaction is so high in volume that it becomes extremely complex for humans to review manually each transaction and how to find out if the transaction is fraudulent. So, as to tackle this problem, we have designed AI based systems to learn what types of transactions are fraudulent. Now, I have a question for you guys. Can you guys think of an application of ML that we as students hate or probably hate? Um, I'll give you 30 seconds to think about this. It is an application of ML that we as students hate. Can I see some answers? All right, I'll give you a hint. Um, so when professors or teachers love this tool because when they check our assignments to see if the content has been copied from somewhere, it helps them a lot to check if we've copied it or if we've done it originally. Now, can you guess what the tool is? Exactly. I saw one answer saying plagiarism. Exactly. So this tool is also based on ML, and ML algorithms are used to build a plagiarism detector. Many schools and universities demand these checkers to analyze the skills of students. And I can pretty much go on with this list of machine learning applications. But let's jump into the technicalities of it. Okay, so what is machine learning? Machine learning is a system of computer algorithms that can learn from example through self-improvement without being explicitly coded by a programmer. Machine learning is a part of artificial intelligence that combines data with statistical tools to predict an output that can be used to make actionable insights. The machine receives data as input and uses an algorithm to formulate answers. But think about it. Why do we need ML? We were doing pretty good with traditional programming, right? We made most of our technological advancements through traditional programming. So let's compare these both and arrive at a conclusion as to why machine learning is taking over. Traditional programming differs significantly from machine learning. In traditional programming, a programmer codes all the rules in consultation with an expert in the industry for which software is being developed. Each rule is based on a logical foundation, and the machine then executes an output following the logical statement. And when the system grows complex, more rules need to be written, and it can quickly become unsustainable to maintain. Because on a daily basis, we have so many problems to tackle. And for each problem, you have to write a new set of code, a new set of rules, which becomes cumbersome. And this is where machine learning comes into play. Machine learning learns how the output and the input data are correlated, and it writes a rule. The programmers do not need to write new rules each time there is new data or there are new problems. The algorithms adapt in response to new data and experience to improve efficiency over time. Now we've talked about the applications of ML, the definitions of it, and even compared it to traditional programming. But why is it so important to have ML in this era? And why are so many people wanting to enter this field? The answer is data is growing day by day. And it is impossible to understand all of the data with higher speed and higher accuracy. More than 80% of the data is unstructured. That is, videos, audios, photos, documents, graphs, etc. And finding patterns in this data on planet Earth is impossible for human brains. So, human brains have created machine brains to do this process for us. And the time taken to compute this would only increase because of the increase in data in everyday life. And this is where machine learning comes into action to help people with significant data in minimum time. To think of it, it does sound similar to a new child learning from itself, right? Instead of a child, it's a machine learning by itself. You give it a set of rules and you train it to learn by itself. Now that we've answered what is machine learning, I have a question for you all. Do you think the term machine learning is an apt name for this technology? I assume that you have understood what the process of machine learning is and what it does. So, do you think machine learning, the two words, combining its name for the technology, is an apt one? Do you think it is perfect to define the technology? I will give you some time to think about it. Do you think machine learning is the right name to describe this technology? It's okay if you go wrong. Please give me some answers. All right, I see some answers here. So let me give you an explanation for it. I think machine learning is aptly named because once you choose the model to use and tune, that is, improve it through adjustments, the machine will use the model to learn the patterns in the data. And then you can input new conditions or observations and it will predict the outcome, right? So I think the name is perfect for the technology or the process that it is doing. Now let's take a look at some of the different types of machine learning algorithms. As we've mentioned, there is a whole host of different ones out there. Here we'll cover some of the basic machine learning algorithms. Many problems that ML sets out to solve require a bespoke approach, such as the types of instructions needed for each problem will be different. However, there are generally four main categories that these algorithms fall into. The first one being supervised learning. In supervised learning, the machine is taught by example. That is, the labeled data is used to train the algorithms, and the algorithms are trained using the marked data where the input and output are known. Next, we deal with unsupervised learning, which is the second type of machine learning algorithm in which unlabeled data are used to train the algorithm, which means it is used against data that has no labels. What is being shown must be figured out by the algorithm, and it is left for the interpretation of the algorithm. And the large data sets and addresses should be addressed by the algorithm accordingly. The algorithm tries to organize the data in some way to describe its structure. It could be grouping the data into clusters or arranging them in a way that it looks much more organized. Next, we have something called as semi-supervised learning. Semi-supervised learning is somewhat similar to supervised learning, but instead it uses both labeled and unlabeled data. Labeled data is essential and has essential information that has meaningful tags so that the algorithm can understand the data, while unlabeled data lacks that information. By using this combination of both labeled and unlabeled data, machine learning algorithms can learn to label the unlabeled data. Next, we have reinforcement learning, and the picture for that is shown above. Reinforcement learning focuses on regimented learning processes where a machine learning algorithm is provided with a set of actions, parameters, and end values. And by defining these rules, the algorithm tries to explore different options and possibilities, monitoring and evaluating each result to determine which one is optimal. This process is done by a trial and error method. It basically learns from its past experiences and begins to adapt its approach in response to the situation to accept the best result possible. Now, I'm going to talk about how, when you search something on Google, how the machine learning algorithm functions, and you get a result there. Here, I'm going to show you an example of when you search for lion images on Google search, and it gives you an output. So Google is incredibly good at bringing relevant results, right? But how does it achieve this task? Google first gets a large quantity of examples or data sets of photos labeled tiger. So let's deal with tiger here because the output is tiger. When then the machine learning algorithm looks for patterns of pixels and patterns of colors that will help it predict if the image is of a lion or if it is of a tiger. At first, Google's computers make a random guess of what patterns are good in order to identify the image of a tiger. If it makes a mistake, then a set of adjustments are made in order for the algorithm to get it right. In the end, such a collection of patterns will be learned by large computer systems modeled after the human brain that once trained correctly identify and bring accurate results of tiger images on Google search. It's pretty fascinating to know that how Google has a data set of millions and billions of images, but it gives us an output in milliseconds, right? Now, this is just the beginning of the session. We have something in store. We have great project, a hands-on project. So we hope you stay till the end. Now, my friend Tisha is going to take over, where she will talk about the language to be used for machine learning and also help you through a hands-on project.
Hello, everyone. Okay, is my screen visible, Harika?
Yeah, it is.
Okay. So, hi, I am Tisha, and I will be taking you through the practical applications of machine learning using Python. So, before we start, I would like to assure you all that it's a safe space, so have a growth mindset and be interactive. And don't worry to give wrong answers, and just be interactive. That's it. Okay, so I guess it's time to start now. Well, I believe that Harika must have fascinated you all by the role of machine learning. So before we jump onto the practical session, I would like you all to think of some of the applications of machine learning that you want to build as data scientists in the future. You all could go ahead and type your responses in the chat box. We'll put a timer of 30 seconds for you to type your responses. Okay, so this brings me to the second slide. So you all can see that the girl in the left side is discussing the role changing position of artificial intelligence. However, a pun is intended here, as when we start initially, we only do the basic stuff like statistics, programming, and all, which leads to some simple outcomes. But eventually, when you become an expert in this field, then you can obviously make some game changing applications. So now I think it's time when I brief you all about the agenda of today. So first of all, we'll be covering why Python is considered as the most suitable programming language for machine learning. Next, we'll go through the steps needed to build a machine learning algorithm. We will also be discussing the libraries that are used for statistical analysis as well as data visualization. Lastly, we will apply these four concepts to a hands-on project. Okay, so now that we have discussed the topics that we will be covering today, it's time to start our discussion why Python is the most popular programming language for machine learning. Okay, so first of all, Python has a great library ecosystem. So could any one of you here tell me what is meant by a library? Like, what do you understand? Or maybe you could give a few examples of libraries in Python? Like the basic libraries that you might be using every day for programming, or that could be used for machine learning, anything. I'll wait for a few seconds, and then we'll be moving on to the other applications. Yeah, yeah. Yeah, so we got a few responses, and it's very good that you know that NumPy, Pandas, TensorFlow, like all these libraries are used in Python. So basically, a library is a group of modules that include a pre-written piece of code that allows the user to perform different actions. Again, machine learning requires continuous data processing. And what Python libraries do is that it lets you access, handle, and transform that data. Okay, so don't worry about it. We'll be discussing more on depth of it in the coming slides. Another upper hand of Python is its fast speed. So this allows the developer to quickly test algorithms without having to implement them. Lastly, Python programming language resembles the everyday English language, and that makes the process of learning more simpler. Its simple syntax basically allows us to comfortably work even with the complex systems. Yeah, so this was all about why Python is the most suitable language. So I think now it's time to move to the generic steps that are needed in any machine learning algorithm. So from here onwards, I would like you all to pay full attention, as these will be the building blocks of the project that we will be creating towards the end of the session. Okay. Yeah. So as you can see here, the primary step is to select a data set that is relevant to a problem statement that you want to solve. So after having the necessary data set, you have to import it using particular libraries or packages. So next, we do the data cleaning and data manipulation. So this basically implies getting rid of extra spaces, removing duplicates, converting lower upper cases to proper case. Also, we could check the spelling, we could make the formatting more proper and other things. So after that, we have a data cleaned. We have to go for splitting the data. So basically, we split into a training set and a testing set. So the first is the training data, where we evaluate the data repeatedly to learn more about the data's behavior. So after we do the training, we go for the testing. So basically, after the model is built, testing data once again validates whether the model will give accurate predictions or not. So after this is done, we get a prediction. So this was all about the steps that are needed in machine learning. So now so this is a summary about what we discussed in the previous slide, that first we have to import the data, then we have to do the data cleaning using pandas, also the data manipulation. Then we split the data into training set as well as testing set. So having created the training and testing set, we create a model. After creating a relevant model for the problem statement, we basically train the model, we make the necessary predictions, we evaluate. And based on the level of accuracy that we have achieved, we may or may not improve it. Yeah. So now let's move on to the packages that are available in Python. So we'll be covering a small set of packages that will be needed for the project. Yeah. So we'll be covering these 4 packages in depth today. That is NumPy, Pandas, Matplotlib, and scikit-learn. And obviously there are many other advanced packages, but for reading the basics more carefully, we'll just go in depth of these 4. So firstly, we have NumPy, which supports large multi-dimensional arrays and matrices, along with mathematical functions that operates on these arrays. Next, we'll talk about Pandas, which is a Python library that is used in data analysis, manipulation, as well as cleaning. It can be used to have data structures as well as the means to quickly perform operations on these data structures. Next, moving on to Matplotlib. So Matplotlib is basically a plotting library. for the Python programming language, where you can make various plots like bar graphs, histograms, pair plots, as well as other graphs. Lastly, we have scikit-learn, wherein we can feature various classification, regression, clustering algorithms, which are very helpful to model, test, and predict it. Okay, so once again, we look into the applications of Numpy. You can see here in the picture that it's used for multifaceted applications like matrix operations, linear algebra, stacking, broadcasting, and many more. Next, you can see here that Pandas is basically very useful to handle the missing data, to visualize the data, to optimize the performance, and generate lots of time series. Moving on to Matplotlib, as I told earlier, it's basically very helpful to visualize the data and analyze it. So by making some of these graphs like bar graph, histogram, scatter plot, area plot, pie plot, we can visualize the data and analyze it in a better sense. And this is basically a cheat sheet of scikit-learn. You can see here that scikit-learn is basically used for so many things, that is classification, clustering, regression, dimensionality reduction. So yeah, so these were some of the basic packages. Okay, so now assuming that you all have just started your machine learning journey, I would like to take you all to a roadmap so that you get an insight into how things needs to be done. Firstly, I would recommend you all to be thorough with the basics of calculus and statistics. So after doing this step, you might move on to the next step where you practice programming languages in either R or Python. And one thing that I recommend is that get very comfortable in it and be familiar with the syntax and the logic behind the code. So after you have mastered these two basics, I would recommend you all to learn the key tools in ML like exploratory data analysis, feature selection, model evaluation, and model selection. So having done these all things, maybe you could start building your profile by getting involved in more projects, hackathons, internships, ideathons, and open source contributions. So this will really help you to speed up your journey as a data scientist. So this was all about the roadmap. I hope it was helpful. Okay, so now that we have learned the fundamentals required to build the algorithm, let's jump to the simplest machine learning model, that is linear regression. So could any one of you tell me what is meant by linear regression, or maybe give me an example? Because I think you might be familiar with this term. I think there's some lag between us. Yeah. So basically, linear regression is the task of predicting a continuous quantity. And by linear regression, we try to predict a dependent variable based on the values of an independent variable. Yeah, so definitely it can be used for the cases where we want to predict some continuous quantity. Now, let's look at how a linear regression model works. So first of all, we try to figure a relation between the dependent variable and the independent variable by using a best fitting straight line. So you can see here that it's a simple model because we take only two variables in this case, and we try to establish a relationship between them. Now, the reason that linear regression is called linear is that both the variables, that is the dependent variable as well as the independent variable, vary linearly with respect to each other. So basically, you can see here that the stock price and the time are linearly dependent on each other. So by plotting a relationship between these two variables, we will be observing more of a straight line instead of a curve because they are linearly dependent. So in this example, you can see that this black value in this best fit line is the predicted y variable, while this blue dot is the actual y variable. So the difference between these two is called the error or the residual. And our aim in machine learning is to minimize the error as much as possible to get the best prediction. So having learned the theory behind it, let's move on to the 5 basic steps that you need to implement linear regression in Python. So first of all, import the packages and classes that I've mentioned earlier, like Numpy, Pandas, Matplotlib, scikit-learn, and many more. Then we provide data to work with and eventually do the appropriate transformations using Pandas, because I've told you earlier that Pandas is used for data cleaning, data manipulation, and data analysis. So we'll do these necessary transformations using that only. So after that, we create a regression model using scikit-learn and fit it with the existing data. So then we check the results of model fitting to know whether the model is satisfactory or not. Having done all these steps, we apply this model for further predictions. So this was all about linear regression. Now, having learned the linear regression model, I think it's time to ideate and brainstorm more. So assume that you are in a real estate business and you need to find a suitable price for the house. So I request you all to bring a piece of paper and a pen and put down the thoughts into the various factors needed to predict the perfect price for a house. I repeat, the perfect price for the house. Yeah. So I'll be giving you 30 seconds to brainstorm on this situation. Then we'll be moving to the demonstration. Okay, so I think you must have thought of the various factors that are needed to predict the perfect price for a house. So now let's move on to the demonstration using linear regression. So basically, what we will be doing today in the hands-on session is that we'll predict the house price using linear regression. We must have mentioned in the WhatsApp group to download this data set, but if for any reason you didn't download it, you can just do it now. So you can go to this Kaggle website. Just a second. Then you can click on download, and then you can extract this a data set into a perfect folder. Yeah. So having downloaded it, you have to put that data set into this file section. So you can click on this upload to session storage icon, and then you can extract that particular data set into this file section. So you can see here it's getting loaded. So it will just take a few seconds. Then I guess we have the data set with us. Yeah. So you can see that we have the data set loaded now in our file section. So let's move on to the project then. Okay. So the first thing that we do is that we import the packages. So as I have mentioned earlier in the session as well, that we'll only be dealing with some of the basic packages today here. That is for data manipulation. we can for data manipulation, basically we use Numpy and Pandas. So using import Numpy as NP and import Pandas as PD, you may import the packages for data manipulation. Also for data visualization, you can use Matplotlib. So import matplotlib.pyplot as PLT lets you to import this particular library. So after importing these two data sets for manipulation and visualization, import this scikit-learn model that lets you to have predictive data analysis libraries. So you can just take a few seconds to type this down in your notebook or any Python editor. Then we can move on to how we actually read the data. Yeah. So I think you all might be done with this. So let's move on to the reading part. So first of all, we'll use a variable housing. So this is a data frame. And using this function pd.read_csv, we read the data as comma separated values. And in the argument of this function, we'll pass the data set. That is, so you can see here that the name of our data set is housing.csv. So we'll just pass it in the argument, housing.csv. So let's run it and see what happens. So we got a green tick. That means that nothing is wrong in this function. So let's move on to the next step, that is analyzing the data. So for analyzing the data, firstly, we'll be using this shape function. So what the shape function does is that it gives you the number of elements per axis. Basically, the dimensionality of the data set, that is the number of rows and the number of columns. So let's move ahead and type housing.shape. And let's see what happens. Okay, so you can see we got 20,640 rows and 10 columns. So now let's see a sneak peek of the data set using the head function. So again, we'll be using this function called head to get the first 5 rows. Yeah, so you can see we have the following attributes in the data set, that is longitude, latitude, total rooms, total bedrooms, and these all. And we have the following records in these columns. But today, as we are only dealing with linear regression and that also simple linear regression, so we'll just be focusing on two variables, that is the y value and the x value. So for the x value, that is for the independent variable, we'll be using this medium income. And based on this medium income, we'll be evaluating the medium house value. So, so you guys just remember that we'll be using these two variables in depth only. So other than that, you need a more effective algorithm to work with more attributes. Yeah. So now, having done a little bit of analysis, let's move on to exploring the data visually. So again, as I've told you, using Matplotlib function, we'll make a scatter plot to see how well the data looks. So again, we'll be using this scatter function and we'll be passing the arguments. That is the medium income and this median house value. You can just copy it from here. Okay. Yeah. So yeah. So let's see what happens. Yeah. So we got a scatter plot, and you can see that it's a linear regression. However, it's not that strong a relation between these two variables, but it's kind of a linear regression only, so we'll assume that we can work on it. So now that we have explored the data a bit, so let's go ahead and split the data into training and testing set. So we'll be using train underscore and test function to do this task. So you can just follow along with me and type the code simultaneously. So yeah, so x train, x test, y train, y test, train, so so for the independent variable, again, we have the median income. So we just type that out. Median housing dot median income. Yeah. And for the y variable, we have housing dot median house value. And we'll be using the test size as 0.2. So by 0.2, we mean that we'll have 20% of the testing data and 80% of the training data. So let's move forward and create an instance of linear regression. So we'll be storing this instance in this variable called linear reg. You can use any name, but I'll be using this linear reg variable, and I'll be storing a linear regression into this instance into this. So we'll just run this step and run the instance step, and now we have to fit the model, which means we have to generalize this to similar data to that it was trained. So using the dot fit function, we'll be doing the step. So I request you all to keep following along, and if you have any problems, to type it in the chat box so that we can look into it and solve the problems as soon as possible. Yeah. So now let's move on to the step linear reg dot fit, and for the first argument we'll have the X training data. Sorry. And for the second argument, what we have is Y training data. But we'll be doing a little bit of modification in X training data so as to adapt the size of the Y training data. So you can just see here, np.array, and we have it in the argument dot reshape. Basically, it changes the shape of this first argument. Yeah. So we have done the fitting. Now let's move on to the prediction step. So again, I'll be storing the prediction in a variable called predict. You can use any variable of your choice. So let's move on to the step. So again, my instance name was linear reg, and I'll use the predict function to make a prediction. And for the first argument, I'll have the X testing data. Again, I'll be doing a little bit of modification here also by using the reshape function, so as to have a perfect dimensionality for this testing data. Yeah. So now let's run it and see what happens. Yeah. So we didn't get any error. So let's move forward. So now we have done the prediction. Now let's check the actual value of the housing price using the head function. So we'll store the actual price in a variable called actual. But obviously you can use any other variable of your choice. we have stored this. Now let's see how this actual variable actually looks. So we'll call this in the next step, and let's see what happens. Yeah. So we got the house prices in this actual variable. So you can see we have these following house prices. Now let's move on to the most important step to see how much this predicted house value differs from the actual house value. And for a perfect machine learning model, we want this residual to be as small as possible. So let's see what happens. So predicted was stored in pred variable, and actual house price is stored in the actual variable. So let's run it and see what happens. Now we have to call this also residual. Okay, so you can see we got this residual. But one thing that we can analyze from this residual here is that yeah, sorry. Yeah. So that it isn't that good, but considering that the house prices are in lakhs and crores, we can go ahead with this because the difference is only in thousands. So now that we have the residual with us, let's calculate the root mean squared error. So we'll be using this mean squared error function, and we'll pass the actual and the predicted value as the arguments here, and we'll be taking a square root of it. Yeah. So basically, we got a root mean square around 83,432. So basically, this is used to evaluate how concentrated the data is around the line of best fit. We can see that it's not that great, but again, we could use it because the house prices are in lakhs and crores. But for more accuracy, you might prefer to use more advanced techniques and try different algorithms. And using cross validation technique, you might check which works the best for this particular data set. So this was all about the hands-on session. I hope that you might have followed along and actually enjoyed building a model for predicting the house price. Okay, so now let's move on to the Q&A session. Okay, so does anybody have any question here?
We're willing to answer any question that you have, be it a minor one or a major one. Feel free to ask any questions. Okay, I see one question. What are the different types of machine learning algorithms and their subcategories? All right. As I've mentioned earlier, there are four broad, but the three broad ones are supervised, unsupervised, and reinforcement learning. Supervised is further divided into three other algorithms, such as classification, regression, and ranking. You hear the word classification and regression a lot, and I think Tisha also spoke about the regression algorithm. In unsupervised learning, you have four different types of algorithms: clustering, segmentation, associate mining, and dimension reduction. In reinforcement learning, you have three other sub-algorithms called reward system, decision process, and recommendation systems. So supervised learning is a task-driven algorithm, whereas unsupervised is a data-driven algorithm, and reinforcement learning is how it learns to react in an environment through trial and error method. I hope that answered your question.
So I guess this was all. Oh,
There's
Alpana has
another
one more
question,
question.
Tisha.
Yeah, yeah. Yeah. So Alpana, so talking about the algorithms, so basically you must be familiar with the basics of all algorithms. However, some of the algorithms that we use in most of the problem statements are artificial neural networks, logistic regression, linear regression, knife-based support vector machine, and linear regression that we have discussed today. Basically, it depends from situation to situation, but it's recommended if you are thorough with these basic algorithms. So I hope this answered your question. Hi Nanya. It's recommended if you know Python or R, but for beginner, I would recommend Python because, as I told earlier, it has very simple syntax, so you could even work with the complex systems. I hope this answered your question, Ananya. Uh, Okay, so the question is that as a beginner, how can you start your ML journey? So in the presentation also, I showed a roadmap stating the basic things that you could do. Firstly, the first thing that is stated was that get familiar with the statistics and the maths behind machine learning. Then after learning the basic concept, maybe you could move on to the programming languages. Okay, so now having learned these two fundamentals, that is the basics of mathematics and the basics of programming, you might move on to the algorithms and the basic stuff behind machine learning, like exploratory data analysis, testing, evaluating, and all. So after that, you might participate in more and more competitions so that you get an idea of the network around you. So I hope I answered your question. Okay, so I see no more questions. So I think it's time we can leave. So what do you think, Harika?
Yeah, I think that's fine.
I think now we should come to an end of this session because we don't have any more questions. So thank you, Tisha and Harika. It was a very amazing session on machine learning. I think now we have mastered a bit of our technical skills. Through this event, we got to know quite a lot of new things, which we would be carrying forward with us in future. We now come to an end of our tech series, Master Your Basics. I, on behalf of IEEE-WIE, would like to extend our heartfelt gratitude to our speakers, Tisha and Harika, for a great session. I would also like to thank all the participants for your active participation and cooperation. For one very last time, thank you so much for making this event a success. Hope all of you all have enjoyed our 3 sessions on your technical skills. Please do follow our IEEE-WIE social media handles to keep yourself updated with such innovative and exciting events in future. Thank you once again. Thank you.
Thank you so much, Roshni, and everyone for being a lovely audience.
Yeah, thank you for joining us today.
Yeah. Thank you, everyone. We would be ending the session soon.